I'm Sterling. Hi, Larry. I work for ZipRecruiter, and as Andrew pointed out earlier, I'm obligated to tell you that we are hiring. My talk today has nothing at all to do with anything we do at work. This is all like basically a bunch of fun projects I've done over the past year, and I'm just going to tell you about what I did. So the Perl 6 part is mostly because most of my fun, optimized for fun projects are in Perl 6, just because I like Perl 6, and I figure if I'm going to be screwing around in my spare time, I might as well enjoy the language I'm working in. Raspberry Pi plus Arduino plus Perl 6 equals fewer interruptions is the name of this talk, because the inspiration for it was the on-air light that I'm going to tell you about. So I'll let you know right ahead of time that there is some blue and red flashy lights. So if you have a problem with blue and red flashy lights, this might not be the best talk for you, but just to get that out of the way. So these people are pretty important to me. This is my wife and 3 boys. The eldest is Gabe, and we got Malachi and Isaiah up there. And I'm already getting gonged. I spend a lot of time around them because we homeschool. And I also work, as I may have mentioned already, for ZipRecruiter, and we're hiring. And we do hire remotes. And I work remote from Manhattan, Kansas, which is a much more beautiful place than you can see in this slide. But I work pretty close to there. The view out of my window is not that good, though, since I work in the basement and I've got an egress, ladder that you can climb out of the window well. So it's not this good view. But one of the consequences of working from home and homeschooling is, you may be able to hear, it's very noisy at my house. This is actually like a year old, but they get louder, not quieter, as they get older. So I invented this thing, which doesn't look like very much right now. But on full brightness, if I turn those all on, these are all RGBW LEDs on the front there that you see. If I turn that to full brightness, you might need to see an eye doctor afterwards. We did kiwi crates a couple years ago. I think I still have one of them I need to do with my kids. That's just sitting on a shelf somewhere. But kiwi crates are really fun. And afterwards, we have all these boxes that we had to recycle, and I decided to reuse one of them instead. So I made it into my control panel, and inside is a little Raspberry Pi. And on that Raspberry Pi, I have a little bit of Perl running. Perl 6, actually. Okay, so here's the final warning for the flashy lights. Get out now. So here we go. Here's the light. I turn it on when I go into my office, which is just right next to this. And this is off the rec room in our basement where my kids play about half the time. So this is the dad's in his office light, just to let them know that I'm there, and just because it has to do something while it's on, so I know it's actually working. So then when I start a meeting, I go and I have this really cool switch. I flip that on, and then it changes its mode. And I figure if I'm going to have an on-air light, it might as well be an awesome on-air light, because, a red light is just boring. Okay, sometimes my kids don't listen. So I have this button. Oh, yeah. So a couple weeks ago, I was home and I was working and I had a meeting and I turned it on and they had friends over and I turned on the light And the flashy light, and they were still being loud out there. I could still hear them. I turned this on, and I could hear my middle son going, "Shh, Dad's in a meeting. We're supposed to be quiet." They didn't get any quieter that particular time, but that's okay. I wasn't talking in the meeting. I was mostly showing off for their friends. And then it switches after 30 seconds back to the regular mode, so they're not always blinded. My eldest son hates that flashy mode, by the way. And then I can turn it off when I'm done. Very exciting. All right. Woo! And I'm really proud of this screensaver. I watched a number file video, and they were talking about mathematical piles and things like that. And so I made this modeled off of after that, so it's kind of fun. All right. So I made a project to sort of put all this together. So I've got like multiple projects now, and I wanted someplace to put it together under. So I needed a name for the project, and as a friend of mine recently pointed out, the 3 hardest problems in computer science, and I'm going to forget one of them, is caching. Let's see, it's caching, naming things, and off by 1 errors.
I think you're off by 1.
Off by 1 errors. So I'm sorry, I screwed up the joke. It's 2 off, you're right. The 2 worst problems in computer science are naming, caching, and off by 1 errors. There, now I got it right. So this is my son. My eldest bought this for his, my eldest plays the electric guitar and bought this present for Christmas for my youngest with his own money. And you can't hardly hear it. My Suko Wewi. So I decided to name the project for all of these things, My Suk. That's the name of the project. Okay, so coming up to the second project, my youngest, he's a little older than that now, since Christmas was a while ago, is now old enough to wake up at the butt crack of dawn and get up his parents and annoy them. And we don't like getting up before 7. Actually, we'd prefer to get up after 7, but 7's kind of like, well, that's a compromise point. And for our other kids, the other 2 kids, they went through this same phase. And when they went through that phase, I bought one of these for my eldest. And this particular device is a Toddler clock. And it's a night light by night, and it turns, I think this one turns green when you set it to go off. So at 7 or whatever, you can tell it to turn green. And then that becomes the authority that says when they're supposed to go to bed and when they're supposed to get up. And it's amazing. Parents aren't good authorities, according to your children. Like, you don't know what you're talking about, Dad. But this device is magic. My kid, my youngest son will tell me it's not nighttime yet, even though it's dark outside. And I will say, go check your clock. My clock is yellow. It's time for me to get ready for bed. It works. However, this particular clock is satanic. My second son used the same clock, and it lasted for most of the time we needed him to have it. But towards the end, we let the batteries get low one day. And overnight, 3 in the morning, the engineers that designed this clock decided that the right way to handle a low battery light, or low battery, so the indicator is boop, 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 boop. So I wake up to my son going, ah! He did not ever want that in his room ever again. So I decided with the third child, we're not going to do that. So I made this instead. So that little lemonade container down there, we reuse a lot of things in my house. That little lemonade container down there contains my own Toddler light. So here it is being a night light at night. And here it is when it's morning time. That's what he calls it, morning time. And it's actually this stack of 3 things. At the bottom there is an RTC chip. In the middle is an ESP8266 chip, and on top is a 4x8 NeoPixel array. And all of this stuff came from Adafruit because I think Adafruit is amazing. So I buy most of my stuff from there. And the nice thing about using Adafruit is that I'm just a dumb software engineer, and hardware sucks. But when I plug things together from Adafruit, it just works. So they've figured out how to make sure that all of the, the right diodes and resistors and all that stuff just sort of, it's magic. And as far as I'm concerned, there's magic smoke inside those things, and that's all I need to know about. And I'm only lighting every other light because even on the dimmest possible setting on this, it's too bright. So I could use this as like a flashlight or something if I wanted to. Okay, so that moves me on to my next point, which is my son has this great book, Don't Push the Button. I don't know if you have a young kid, this book is really fun. It's basically just don't push the button. And then bad things happen when you push the button. And then in the end, you're like, oh, that was kind of fun. Let's push the button anyway. So my idea is to turn the toddler clock into a toy. The next level is I'm going to, I have a 3D printer too. I'm going to use this button and this 3D printer. And I'm going to make a button on his wall that says, it's got a label on it. It says, don't push this button. When he pushes the button, it makes his light go do crazy things. So, which brings me to my final project, which is this thing. My battery must be going low because this doesn't look as bright as it did there. And so for this talk, I thought, well, wouldn't it be fun if I could have something to bring that people could interact with? And so I put together this thing. So I 3D printed it. I think I went through like 12 prototypes to finally get this all printed up right the way I want it. And then, again, it's another one of those ESP chips. It's actually the new one, the ESP32 this time. And this is a 6x12 dot star matrix instead of a NeoPixel matrix. They're a little more expensive, but they can get smaller, and 4x8 is really hard to put like letters on that are readable. So I went with this. This is kind of hard to see. I'd love for you guys to all be able to see this, but you'll just have to come up and see it later. But what I did was I programmed it with Perl. So I think this is the part where we must read the code. So I'm going to bring up some of the code I worked on, and we will take a look at it. That is too dark. I meant to switch the profile to something more readable first. I have one, or used to, that was just for this purpose, and of course I forgot to set it up. No, that's the wrong thing again. Session, there it is. Text, colors. There we go. Okay. Can you see that in the back, guys? All right. All right, first thing I wanted to show you guys was, so here's the async code I actually have running on the Raspberry Pi. This is getting like weird. I'm gonna maybe just do this. I can't do that, never mind. Okay, that's what I wanted anyway. I meant to do that, guys. So this is using RPi, which is a really cool Perl 6 module that somebody's already put together. I can't remember. I'm sorry if I'm not mentioning the author here, but I should. So this is the code that's running the running the control panel, and all it does is it sends a signal. It's actually the stupidest, simplest signal possible. It sends a UDP packet containing 0, 1, or 2 as the sole byte to switch it from one mode to the other. So my kids could totally flip the switch anytime they wanted to if they, just pulled up something to send a UDP packet. Or anybody could on my network. Security is what I do for ZipRecruiter, by the way. So my idea was that if my kids got interested, I could just say, well, here's this little program you can run to switch the mode. My hope is actually to get everything running the light to be doing the same thing my nametag is doing, which I will get to in a bit, I hope. Yeah, I should be good. Here we go. So here I got some stuff to set up the pin, and this is just like some administrative stuff, so this is not that exciting. This is basically, a Raspberry Pi has on it a bunch of general purpose I/O pins that you can basically say on or off. And so this is a class to help control the pin mode, whether up or down. So here you go, toggle, turns it high or low. And then also, I also have it set up so that it will poll the state of the pin every so often and emit events when the state changes. So I can monitor the current value of the pin if I want to, which is kind of important if you're going to have switches. And then I have signal state. And then here is the stuff that interacts with the light panel. So the light panel is just a thing that we send a UDP packet to. So it's pretty simple stuff. I'm not going to go over, this stuff is not that interesting, so I'm going to skip to the stuff that's more interesting. So here's send state update is the thing that actually communicates with it. And let's see, send state update. So there we go. Send state update. Where's my mouse? This thing right here. Basically, it writes to port 10101. That's the only thing that's the only security, is the obscurity of the port number. And it sends a single int. And actually, it's since I'm using blob there, it actually ends up being converted to a byte, and sends a single byte that contains 0, 1, or 2, which is basically, I think, set in this. Yeah, that's that enum up there. Those are the 3 states. Very exciting. And then, thank you, Doran. So, do you mind if I just hold on to the mic for the rest of the talk? I think that might be easier for me. I don't mind. Okay. Okay, so then we got the control panel, which pulls it all together. So what do we got? We got the on-air button. So that's the switch. It doesn't really matter if it's a button or a switch. I mean, it's just a thing that that connects a pin, closes a circuit or not. The quiet button, which is the button you push. In that case, the way you treat these is different, of course, because a toggle button is one that's or a switch. You flip it on, and as long as it's on, you want it to be considered on, and then you flip it off. And with a button, you push it down. And in this case, I want the mode to stick on for a little while. So. And I have to say that after this amount of hardware programming, I have a lot more respect for people who do embedded programming for real, because Arduino makes a lot of this stuff super easy, and having to deal with things like debouncing and all that stuff, I have a lot more respect. And figuring out all the little nuances of user interface, of course, took a long time. So we have all these tests. So these are using those high-level things I created in that pin class to basically test each time if it's currently in whichever state. And then we have, these are kind of cool. At the top there, the on-air events and the quiet events. So these are basically asynchronous supplies. So if you went to the talk on event programming. In Perl 6, event programming is just sort of baked in. And one of the ways you do that is you have these things called supplies, which are kind of like asynchronous lists, and they just emit values as they come in. And so you can do cool things like run map on them. And so every time a new event comes in, you can transform that thing from one thing to another. So here I'm transforming it from high-low to true-false. So I can test if it's on air or not based on whether the most recently emitted event was true or false. And then I have this class that sort of generates that. So you saw when I pushed the button for the flashy mode, the light blinked on and off every half second to let me know that it's still letting my kids know that I really want them to be quiet. So I use really technical variable names like Blinky Blinky, by the way. So here again, we have another supply here to generate these Blinky events. So we basically, I have it doing an interval at blink frequency, which I think I set at half a second, and then it toggles the light on and off. One thing I want to do that I haven't done yet is the Raspberry Pi has what's called a PWM on it. I have no idea what that stands for. It's more electrical engineering magic. But I know what it does. It generates pulses, up and down pulses. And so what I want to do is control the PWM and put the thing on that, and then I can have it do things like glow, so I can make it gradually get brighter and go out. I don't know, that would be cool, wouldn't it? This is all fun stuff for me because I've never done hardware programming before. And then here's how we stop it. And then we have our main. So another thing, if you're not familiar with Perl 6, Perl 6 has this cool, super awesome feature built in where you can declare, instead of having used an external module like get_opt, you can just say, I need a dry run option, and it defaults to false. And then when you run this script, you can do -- dry -run, and it sets that to true. And then I have a required panel IP, which is the IP address to send those UDP packets to. All right, so we do some setup, and this all pulls it together. Dot equals is a operator in Perl 6, which does not mean concatenate. Concatenate is tilde equals, because tilde always means strings, and plus always means numbers. And dot always means calling a method. So Perl 6 tries to be consistent on that sort of thing. And so here what it does is light is you can see that I've typed it, my light panel light dot equals new, means call the new method on it and assign the return value back to the variable we called it on. So that's like a shortcut for calling constructors that I use a lot. Okay, so here's the guts. React is activating the event, activating the event loop. It basically says inside of React, we're going to loop over everything that happens in here on a single thread. So everything that runs in here only happens on one thread, unless we request a separate thread. You can use a start or something like that to start a separate thread. But React says everything runs in here on one thread, and then all the whenevers are watching for events. So whenever I get an on-air event, so the on-air event is the switch being flipped, and when it goes to true, then I tell the light outside my office, go on air. If it's false, then I tell it to go off air. And I only get events whenever that changes, which is cool. And I'm going to skip the keep with early quiet because I can't remember what that does. And then whenever there's a quiet event, So that quiet event is what I called up, me pushing the button because I really want them to be quiet. Then we have more complicated code because, of course, now we're starting something and we're going to run it for a little while. So we're going to go into an emergency mode, and then we're going to shut it back off. So here I use, I basically say a promise. Okay, here we go. So we start the quiet blinker, which starts running the blink on off stuff. And then we create this promise to remember the duration, and basically this promise here, or it's any of, so any of these promises can be concluded, and what we want to convey, what I need to convey here is, if I flip the switch off, say it's in emergency mode, and then my meeting suddenly ends, and I flip the switch off, then I want to clear emergency mode so that if I immediately flip the switch on because I made a mistake and want to hit that button again, then I can, like, all the states clear each time. So there's two possible ways to turn off out of that, like the police light mode, which is either I flip the switch off, or I'm going to quit after 30 seconds is up. So when either of those promises are kept, then I want to turn the light back off. So that's what that then does. So you can read this as, when any of those two things in there happen, then keep this promise and do those things. And that's pretty much it for the control panel. So I'm pretty happy with this code. Like, there's actually a lot going on in here, and some of it I have to think about to remember what it does, but I think it's all really pretty clear overall. And I mean, this file is only 267 lines long, which I think is pretty cool. So it's a really concise way of describing it, and that's including all of my extra comments in there to help remind me, because I work on this code never. So, like I said, I kind of want it to do what my name tag is doing, but I haven't gotten there yet. Okay. Let's go to... I didn't realize it went black there and you guys didn't complain. I hope you could read that. I want to go to client. All right. So that brings me to my name tag. Okay, so I've got this on here. I've got all the code on here is C++. And this is a Perl conference, so I'm not going to go over that. But if you guys want to see it afterwards, I'll totally show it to you. Or you can go to github.com/zaste/mysuk. Mysuk away we. But let's look at this real quick. All right. So this is the programmer for my name tag. I really wanted this to work with like a web service, and it would pull stuff in and whatever. But I didn't get that far on my work. So there's really not a lot here. The main thing is that the programs that run this are all in like a pseudo Perl 6 like domain-specific language for programming this thing, I use eval file to just eval the programs there, and then to load it onto the name tag, it is really dumb. That's it. It does a post, and the name tag is running a web server that's on our Wi-Fi. So all you got to do is post some binary data to it. So what I haven't gone over is the magic that's going on in name tag program builder, which I'll get to in a second. Yeah, so basically all you got to do is shove bytes at this thing over HTTP, and this is like the dumbest HTTP server too, so it's probably all kinds of like stupid, but curl would do just fine. Let's look at one of the programs real quick. Oh, I renamed that. It's named, typing with one hand is hard. Let's look at this one. So my youngest, every time he'd see letters on it, he'd go, "It says Isaiah." So I made one that actually says Isaiah. So this is what the programs that in the high-level language I've made, which is really awful. It's like just barely past assembly. .fun declares a function. It's named nametag. The strings are all, so every function is actually given a numeric index in a lookup table, and the strings are just for reference inside of this high-level abstraction. Same thing with the variable names. They're all stack offsets like you would expect. And this is just my first round. I have some other ideas on how to make this cooler, but let's get this cruising first. So here I'm going to set variable name foreground to FFFFFF, which would be the color white. I'm going to declare a counter variable. All the variables have to be declared at the top, just like old style C. And then a marquee position, because a 12 width screen is really not big enough to do any more than 3 letters. So we have to scroll it across. Urgency is, so I have this notion of a tick happening every so often on the system. One tick is every 50 milliseconds. And urgency says how many ticks do I skip before I do something. So you can basically say, I don't want to do something very often. So in this case, I have it skipping every other tick. And then set brightness. The brightness is ranged from 0, which is off, to 255, which is blinding. I actually have the name tag cap it at 75, because 75 is about the brightest that I would want to allow out of the front of the name tag. Any higher than that, and I'm going to have people like, turn that thing off. Like walking down the street, I'm going to have people like crashing their cars. No, probably not, but. And then we have this loop. And through the magic of operator overloading, I'm doing all kinds of weird things here to generate the actual byte code, which is actually double word code, not byte code, because I'm lazy. So here it sets the color to a random thing, and then it ORs it with C0, 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 which guarantees that it'll be a bright enough color to actually see, show up. And then we loop inside of that to show this thing. So the .put text puts the text, Isaiah! And then every time through, it does its thing. And this is actually running in its own event loop on the name tag. So it's kind of like a coroutine in some ways. That tick basically says yield. And it also says draw. So every time you do a dot tick, it says yield control back to the name tag firmware and draw whatever I've told it to write out. With the emphasis being that the whole point of this is to draw something. So if I forget to put tick on there, which I did earlier today and realized I'd forgotten to put in the safeguard to make sure that tick can't go forever, because then it would take control away from the firmware forever, and then you wouldn't be able to upload anything until I reset it. It actually limits the number of ticks to, or the length, the slice this program is allowed to have between ticks is 25 milliseconds, I think. So that's all the time it has to run before it gets told no. Anyway, that's pretty much it. Oh, and then it pauses for 4 ticks between showing his name again. and restarts. Oh, and I should say, it may not be clear how the marquee is like each iteration, it's moving the marquee over one position by subtracting one here, where it's doing this set marquee position in the middle, right here. One of the things put text does is it sets a register, so they're like 16 special registers at the bottom, and one of them is the X cursor and the Y cursor, and the X cursor gets moved to the end of the lettering, so I know how wide a given string is. So anyway, that's how it knows to do that. And then at the end of each tick, it goes back up here to this outer loop, and picks a new color and starts over. All right. So this is the part where my volunteer, if he wants to, can follow along with me. And so the programs are in, oh gosh, I renamed that. I keep forgetting. So these are all the example programs. So if you want to, pick one of those and you just say name tag dash load program equals, and then dagnabbit. And then pick a program. Should pick like rainbow or police. Those are really exciting. And then hit enter, and it should automatically load, unless something's messed up. Yes. Oh, I didn't mention this is running MDNS and announcing itself too. So it actually has a name in Bonjour or whatever it's called now. It's nametag-zoste.local. So it should automatically do it. Did it work? Did it work? Did it work? It'll take a second. Did it fail?
Give me a user's message.
Okay. Did you get it?
What's the exact syntax supposed to be?
Just like this. It should be. What do they do? Name tag load.
Running from which directory?
Oh, I have this totally wrong. Okay. I'm going to do...
Do you have to be in a certain directory?
No. If you installed it, it should be fine. But here's, I'm running it locally. So it tells me what the bytecode is. So you can see all the nice bytecode there. It's, again, not really bytecode. It's double word code. And here now it's doing my program here. Yeah. Well, I have all this like ZipRecruiter swag because ZipRecruiter is hiring. So you may pick one of the swag items for making the brave attempt, for being my guinea pig. So I have 2 hoodies and little batteries that say ZipRecruiter on them. And I still have 3 other pieces, after whichever he uses. So here's...
That's the result.
Dash program equals, and it caused interference. I don't know. We'll talk later. Anyway, anyone who can put their name on my name tag is welcome to any of the other items. So all you have to do is go to github.com/zoste/mysuk.
Could there be an implicit module dependency for the argument parsing to work?
No. It's built in. Okay. So how are we on time? I got like another 10 minutes, right? Okay. The other thing I wanted to talk about was No, I don't want to talk about that. Is there any, let's do this. Any questions? Anything you guys want to see? Yeah, John.
Yeah, so a couple of months ago, I tried to compile a record on my Raspberry Pi 3 and it didn't work. Like, it got really hot and it failed eventually. Is that normal?
Getting really hot is probably normal. My experience with Raspberry Pi is that it gets really hot on a dime whenever you make it work hard. I have a heat sink on mine actually, or on the one that's in that control panel. I actually have like 2 others doing other things. I didn't have any problem compiling it, but I compiled it 8 months ago, and I haven't touched it since. I don't know. Now that I'm thinking about it, but I don't remember having any. I don't. Were you running a GUI when you did it? I don't know, but I know I got it. I know I got it to compile. I know Peter also got it to compile. Zofix, whom I've never met in person. Any other questions? You guys want to see like C++ code? I think I have time for it now. We can go see C++ code. By the way, I officially despise C++, but I should probably just write more of my stuff in just plain C instead of C++, because I can tolerate that better. Let's see, where am I? Right. Device, name tag.
I think I figured out why it's not working. It looks like it wants the host.
Well, you can give it the host. It's host -- host equals name tag -zoste.local. All right, so, and this code's kind of hideous, I will admit. Which one did you pick?
It still works. I picked that one.
Oh, then it probably changed.
Well, it's dumped a bunch of code.
Yeah, it'll dump codes to the screen because I have to.
It did say to fail to resolve.
Go ahead and do it again, and see. I just reset it. Although it may take like 30 seconds to get onto the Wi-Fi and start up the server again. All right. So some of this is kind of ugly because I have this thing where I have this thing. I like making simulators that run as graphics on my local machine instead of programming all the time. So some of this stuff is a little noisy. I'm using, like I said, Adafruit stuff. And one of the nice things about Adafruit, beyond their hardware work and just building really solid electronics, is they provide open source libraries. And so they have this thing called these matrix objects that they have that are basically C++ classes to set up matrices. And the initial setup, like this thing looks complicated at the top, but this is amazing. Just these few flags, you can do all kinds of insane things. Like, so they know that a lot of people will do it, like be lazy like I am, and they will buy, to make a bigger screen, they'll buy a dozen of these little tiny matrices or something. And so you need to make a big matrix out of a lot of little matrices, which might be arranged in who knows what fashion. And they have code that will just generate the offset tables to make sure that when I say pixel, 42, 117, it picks the right pixel on the right, panel. So you can do a bunch of little setup right up here. So you set 12 by 6 is the size of the little panel. You set the data pin and the clock pin, which are just the 2 pins needed to do the I2C protocol to control each of the individual. So each one of these little LEDs has its own chip. Thanks. And then The other stuff tells it what order to light them in. And then BGR is the order that the actual pixels are in on the chip programming. So they program in BGR. Okay. Sorry.
Just doesn't do Monjar, I guess.
Maybe. That's weird. I guess.
What's your IP then?
I don't know. I'd have to plug it in and look at the. Maybe I can. Name tag dash sauce dot local. There you go. Everyone smash it at once. There you go. Yay! So MDNS, one of the problems with it is it's a little flaky because it's like you try to ask everything on the network. Are you running a little DNS server? What's your name? Okay, and then the setup comes down here and does some stuff, and then of course most of the interesting stuff is happening elsewhere because I don't put everything in the main file for reasons. All right, so this is a whole bunch of stuff left over from when I programmed it directly, and again, there's not a lot in here, but this is kind of fun. There's a web server in here. So this handles the actual web requests coming in, and it ignores the path, it ignores the content types, it just reads the body as a whole bunch of binary data that is read in as double words. The first, I'm really into complex binary formats, by the way. The first double word is the pointer to the first instruction to run. Or no, it's not the pointer to the first instruction. It's the pointer to the first subroutine index to run. So one of the instructions is an op sub, which gives it an index number, and then that's used as the pointer. So it's kind of like having the line numbers in BASIC. And then all the rest of the double words are the program itself in bytecode. And so most of this code here is just taking each byte and adding it to the double word. So, and it uses network Indian. And that's pretty much it for that. And this is switching. So I have so if I hit the reset button, there's a program built into it so that it automatically reverts to my name, just in case someone. Oh, and by the way, if you do want to program my name tag, just realize that we do have a code of conduct. Please keep it appropriate.
Now wait, when you hit the reset button, did that change the IP?
Yes, it could have.
Is it still the same one?
I don't know. Maybe. Maybe not. You can try pinging that name. And let's see. We'll go look at the VM code. Whoa! Edit anyway. So here's the VM. It's really advanced. It's got a stack size. It's got a 4096 stack size. 250. The heap is actually just the registers. And then I should actually bring up the. No, not that. That's dumb. So here are all the ops. So they're really, so op sub declares a subroutine index. Op return does a subroutine return. Go to jumps to a subroutine. Go sub jumps to a subroutine but pushes the current stack pointer onto the stack. Op tick does the draw. Op no op does nothing. Pretty much a lot of the standard operations. that you would think of, and then a whole bunch of weird ones like operand. You can get a random number pushed onto the stack. Width. You can set and get to set a register, get the value of a register. Fill tells it to fill with whatever the current foreground mode is, or foreground color is. Put char puts a character from the whatever the top level, pops the top item from the stack. This is all using basically reverse polar, the way it works. It was kind of inspired by Forth, except I didn't want to have to create a Forth parser. And there's a halt. And then here are all of the built-in registers, and the first 16 I've said are, for my use for now. It's not like I worry about binary compatibility when I just program out those Perl 6 things anyway. How 3D? Pwn 3D? Pound 3D? Even 6 letters, or like it really only uses 5 of the 6 pixels unless it needs to drop below the line, and it's really hard to read. Well, thank you to my beautiful assistant. I didn't even catch your name. Devin. And thank you all for attending my talk.